State and prove the Taylor's theorem. Now, if a statement if f of z is analytical in a circular domain omega with a center at A, and then for all z belongs to Q, f of z is equal to f of a plus f dash a into z minus a plus f double dash a upon 2 factorial into z minus a square plus so on plus f and a upon n factorial into z minus a raised to power n plus so on is equal to sigma n varies from 0 to infinity z minus a raised to power n upon n factorial into f n a. Now proof, let C be the boundary of a circular domain omega, and let z be any point in omega, z be any point in omega. Let us construct a circle C1 with center at A and enclosing z. Then by Cauchy's integral formula, f of z is equal to 1 upon 2 pi eta integral over c1 fw over w minus z dw is equation 1. Now 1 upon w minus z is equal to 1 upon w minus a minus bracket start z minus a bracket close is equal to bracket starts w minus a bracket close square bracket starts 1 minus taking w minus a common from this. So here remain 1 upon wz minus a upon w minus a square bracket close. Now taking this whole term to numerator, it will come 1 minus z minus a upon w minus a square bracket close whole raised to power minus 1 which is equal to 1 upon w minus a opening this term as 1 plus bracket starts z minus a upon w minus a bracket close plus bracket starts z minus a upon w minus a bracket close whole square plus so on plus bracket starts z minus a upon w minus a raised to power n minus 1 plus bracket starts z minus a upon w minus a raised to power n into 1 upon 1 minus z minus a upon w minus a bracket close square bracket close. Now solving this term, rest of the term remains same. Here w minus a, this will become w minus a minus z plus a upon w minus a. So w minus a comes to numerator and w minus z in the numerator. Rest will be as it is 1 upon w minus a 1 plus z minus a plus z minus a upon w minus a square plus so on z minus a upon w minus a whole raised to power n minus 1 plus z minus n over w minus a raised to power n into bracket starts w minus a upon w minus z square bracket close. Now opening this square bracket, so it will becomes 1 upon w minus a plus z minus a upon w minus a square plus z minus a square upon w minus a cube plus so on z minus a raised to power n minus 1 upon w minus a raised to power n plus z minus a upon w minus n raised to power n upon 1 upon w minus z. W minus a will cancel out with this w minus a, so here remain with 1 z minus a upon w minus a raised to power n upon 1 minus 1 upon w minus z. So that integral 1 upon 2 pi eta integral over c1 fw over w minus z dw is equal to 1 upon 2 pi eta integral over c1 fw over w minus a dw plus z minus a over 2 pi eta integral over c1 fw upon w minus a square dw plus so on z minus a upon 2 pi z minus a raised to n minus 1 upon 2 pi eta integral over c1 fw over w minus a raised to power n dw plus 1 upon 2 pi iota integral over c1 z minus a upon w minus a whole raised to power n fw over w minus h dw equation 2. Now using the Cauchy's integral formula, we have f of n a is equal to n factorial upon 2 pi iota integral over c1 fw over w minus a raised to n plus 1 dw, where n varies from 0 1 2 3 so on. Therefore 2 becomes this equation 2 becomes 1 upon 2 pi integral over c fw over w minus z dw is equal to f of a plus f dash a z minus a plus f double dash a upon 2 factorial into z minus a whole square plus so on plus f of n minus a upon n minus 1 factorial into z minus a raised to power n minus 1 plus un say is equation 3, where un is equal to 1 upon 2 pi iota integral over c1 bracket starts z minus a upon w minus a whole raised to power bracket close whole raised to power n fw over w minus z dw. If we can prove that the limit n tends to infinity un is 0, we will have proved the required result. To prove limit un tends to 0, since limit n tends to infinity un is equal to 0, since w is a c1, so modulus of z minus a of w minus a is equal to gamma is less than 1, where gamma is a constant. Also, if r1 denotes the radius of c1, so we have modulus of w minus z is equal to modulus of w minus a minus z minus a is greater than w minus a modulus minus z minus a modulus, so which is greater than equal to r1 minus modulus of z minus a. We have un modulus is equal to 1 upon 2 pi integral iota integral over c1 bracket start z minus a upon w minus a bracket close raised to power n fw over w minus z dw modulus close is less than equal to 1 upon 2 pi r gamma raised to power n m upon r1 minus modulus of z minus a into 2 pi r1, which is less than equal to of r gamma raised to power n m r1 upon r1 minus modulus of z minus a. Now since because fw modulus of fw is less than equal to of m, and we see that limit n tends to infinity un is 0. Thus from 3 we get f of z is equal to f of a plus f dash a z minus a plus f double dash a upon 2 factorial into z minus a square plus so on f dash n upon n minus 1 factorial into z minus a raised to power n minus 1 plus so on, or f of z is equal to n time varies from 0 to infinity z minus a raised to power n upon n factorial f of n a